Welcome to your Algebra 2 lesson 5.6. We're going to find rational zeros. Okay, so you're going to find all the real zeros of a polynomial function, and the first thing you're going to use is the rational zero theorem, or rational roots theorem. You'll hear it called either thing because zeros and roots are the same thing. If f of x equals an times x to the n plus on and on to a1x plus a0, so you've got a polynomial function that has integer coefficients, then for every rational zero of f, it has the following form. It's equal to p over q, where p is a factor of the constant term, and q is the factor of the leading coefficient. It's very important that you learn that the p's are the factors of the constant, and the q's are the factors of the leading coefficient. So we're going to list the possible rational zeros of f using the rational zero theorem, and we're going to look first at a, which is f of x equals x cubed plus 2x squared minus 11x plus 12. So p is going to be all the factors of the constant term 12, and you have to consider plus or minus for all of them because positive integers and negative integers can multiply together to give you 12. So certainly plus or minus 1 works, plus or minus 2 works, plus or minus 3 works, plus or minus 4 works, plus or minus 5 is not a factor of 12, plus or minus 6 works, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't, 11 doesn't, but 12 does, so plus or minus 12. This is the easiest case scenario of finding q because the q is going to be the factors of the leading coefficient, and our leading coefficient is 1, so plus or minus 1. So now you look at all your possible combinations of p divided by q. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, plus or minus 12 over 1, which simplifies to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So if that function has a rational zero, it's one of these. And so that takes us from an infinite number of possibilities to a listable number of possibilities. Okay, let's look at part B. We've got f of x equals 4x to the fourth minus x cubed minus 3x squared plus 9x minus 10. So we're going to get our values for p. They're going to be the factors of the constant term, negative 10. Again, we'll list positive and negative. So 1 works, 2 works, 3 does not work, 4 does not work, 5 works, 6 does not work, 7 doesn't, 8 doesn't, 9 doesn't, 10 does. So we list plus or minus 1, 2, 5, and 10. Q, the values for Q are going to be factors of 4. Because that's our leading coefficient, so plus or minus 1, plus or minus 2, 3 doesn't work, plus or minus 4. So now we're going to look at the ratio of every p value to every q value. So here we go. It's going to be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 5 over 1, plus or minus 10 over 1. So we're done with 1. Now we're going to come around with a q value of 2. So plus or minus 1 half, plus or minus 2 halves, plus or minus 5 halves, plus or minus 10 halves. Now we need to do the same thing with 4. So plus or minus 1 fourth, plus or minus 2 fourths, plus or minus 5 fourths, plus or minus 10 fourths. So now we want to simplify. And we won't repeat any that give us the same value as something we've already written down in simplest form. All right, so all the ones with denominators of 1, we just divide that out. Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So then plus or minus 1 half, that's new, we write it down. Plus or minus 2 halves, that reduces to plus or minus 1. We already have that. There's no reason to write it again. Plus or minus 5 halves is reduced, so it gets written down. Plus or minus 10 halves is plus or minus 5, and we already have that. So we don't need to write that down. Plus or minus 1 fourth, that's new. Plus or minus 2 fourths reduces to 1 half. Plus or minus 1 half, we already have that written down, so we don't need to write it again. Plus or minus 5 fourths, that's new, so we write that down. And then plus or minus 10 fourths reduces to 5, plus or minus 5 halves, and we already have that. So if there is a rational zero for f of x, it is one of these values. All right, we're going to find all the zeros of a function f of x equals x cubed minus 8x squared plus 11x plus 20. And the way we're going to get started is by finding all the possible rational zeros. So we do the p over q, okay? So our p's would be the factors of 20, and q's would be factors of 1, so it's just going to be 1. So here we've got our p over q, so you can see we've got all the factors of 20 over 1. So the possible values for x would be p over q, so it's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. All right, we're going to test these potential zeros using synthetic division, and we're going to look for ones that give us a remainder of 0. So if we test 1, so again, just as a reminder, you bring down the 1, and you multiply it by the x value of 1 to get 1. Then you add, negative 8 plus 1 is negative 7, times 1 is negative 7, 11 plus negative 7 is 4, 4 times 1 is 4, 20 plus 4 is 24, which is not 0, so we do not have a 0 in x equals 1. So we try negative 1. And when we do negative 1, lo and behold, we get a 0. So we know that negative 1 is one of our zeros. We also know that we have a quadratic quotient here, because it always goes down by 1 degree, of x squared minus 9x plus 20. So our original f of x is going to equal x minus negative 1, so x plus 1, times that quadratic, x squared minus 9x plus 20. Well, with quadratics, we can factor those, or we could use the quadratic formula if we needed to. In this case, we can factor, and then we just set each factor equal to 0. So, of course, we get x equals negative 1 again. X squared minus 9x plus 20 factors to x minus 4 times x minus 5. So we get zeros at x equals 4 and x equals 5. So we have our three zeros, negative 1, 4, and 5. So let's try it again. This time we've got f of x equals 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12. So you do the p over q again, and you reduce. So there are a whole bunch because we've got lots of factors of 12, and then q is going to be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So you get a whole bunch of possibilities here. Step 2 is choose reasonable values from the list above to check using the graph of the function. So if you look here, we can see that there are 2 that are negative that are going to be fractions. So you'd pick 2 negative fractions and you're ending up with 2 positive fractions. Okay? So pick one that seems reasonable, and you're going to check until you using synthetic division until a 0 is found. So negative 3/2 looks like it might work, but we don't end up with a 0. So we go on to another one that looks like it might work. So let's try negative 1/2. So we bring down the 10. 10 times negative 1/2 is negative 5, plus negative 11 is negative 16, times negative 1/2 is 8, plus negative 42 is negative 34, times negative 1/2 is 17, plus 7 is 24, times negative 1/2 is negative 12. Yay, that gives us 0. Okay, so we know that we have the binomial x minus negative 1/2, so x plus 1/2 times our cubic quotient that we had. So if we go back and look right here, we started off with x to the 4, so this would be 10x cubed minus 16x squared minus 34x plus 24. Well, we don't have a quadratic yet. So we're going to have to keep doing synthetic division, but we're going to do it with these coefficients because we want to find one more that works and then get down to a quadratic and be able to use the quadratic formula or factor, depending on whether or not we can factor. All right, now one thing that would be nice is since all of these are even, we can make our life easier by factoring out a 2 and then actually incorporating it, and it'll make life just easier. So we have x plus 1/2 times 2 times 5x cubed minus 8x squared minus 17x plus 12. And we can actually absorb this 2 by distributing it into the first factor here, the x plus 1/2, the binomial. So we'll have 2x plus 1/2 times 2 is 1, And then we've got our times 5x cubed minus 8x squared minus 17x plus 12. So now we're going to repeat the steps from above, but with 5x cubed minus 8x squared minus 17x plus 12. We could have just kept going with the list that we had before, but it would be much larger, and so this actually reduces the number that we have to consider. So this could save us some time. All right, so let's look at the graph of g so we can pick a reasonable starting value. So here's our graph. And so let's see, there's that negative one that we really couldn't find anything for that was going to give us trouble. This looks like it's a little bit further than 1/2. It looks like it might be 3/5, which is equal to 0.6. So let's try 3/5. So we use our g of x, our quotient polynomial, and we bring down the 5. 3/5 times 5 is 3, plus negative 8 is negative 5, times 3/5 is negative 3. Plus negative 17 is negative 20, times 3/5 is negative 12, plus 12 is 0. So the graph of g shows that 3/5 may be a 0. Synthetic division shows that 3/5 is a 0. And so g of x is equal to x minus 3/5 times 5x squared minus 5x minus 20. Now look how each of these we can factor 5 out of, so let's do that. So we're going to have x minus 3/5 times 5 times x squared minus x minus 4. We're going to multiply the 5. We're going to distribute it into the x minus 3/2. So we're going to have 5x minus 3 and then times x squared minus x minus 4. So it shows that it follows that f of x equals 2x plus 1 times g of x. G of x can be factored into 5x minus 3 times x squared minus x minus 4. So f of x is the product of all of those. Now, x squared minus x minus 4 is not going to be factorable. So we're going to have to use the quadratic formula to find the remaining zeros. So we use our x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we substitute in 1 for a, negative 1 for b, and negative 4 for c. And we simplify and we get 1 plus or minus square root of 17 over 2. That is those are irrational zeros, okay? And so we have 4 real zeros, negative 1/2, 3/5, and it didn't copy it here, but 1 plus or minus the square root of 17 over 2. Those are our 2 other zeros. So these up here count 2, even though for some reason it's not showing up there. Oh, there they are. Okay. I just needed to click an arrow one more time. So we've got our 4 real zeros. And that makes sense because in the original graph of f, we could see where the graph crossed the x-axis 4 times. So we would expect there to be 4 real zeros. Okay, that's it for 5.6. You need to check out the 5.7 video next.